see a question. Can you help me understand domain and range? Sure, let me share my screen again. Let us go back to last week's lesson. Let's see if I can find some graphs. Okay. When we are talking about domain and range, domain has to deal with the x values of our function, whatever function it may be. Domain will always deal with your x values that are applicable to your function. When we talk about range, we are always talking about our y values. So if we had to look at this graph over here, if I had to ask you, what is the domain? Let's look at all of the x values that our graph is going to touch. If we look at what we just see, I can see my two x-intercepts over here. We have our x-intercept at A and we have my x-intercept at C. So you would immediately want to say, that's all my x values, but it's not, because we're not just looking at our intercepts. We're looking at the entire graph. And so if you look at the ends, you can see that there's arrows to indicate that our graph is going to continue getting wider and wider and wider, which means in reality what? That we are going to eventually touch all of our possible y values. So, excuse me, all of our possible x values. So if I had to ask you what the domain of this is, there are also two ways to write domain. You can either say from negative infinity to positive infinity. Why negative infinity? Because here on this side of the graph, you can see that my graph is going to continue up until, you can see that our graph is going to continue into negative infinity. And same on the other side, your graph will go through all your x values to positive infinity. So if I had to ask you for your domain, you would tell me, and remember what I said, domain is all our x values. So you would tell me that my domain will be from negative infinity all the way up until positive infinity for this graph specifically. So for every graph, you will have a different picture and you'll have to think to yourself, where are all my x values going to be valid? Where is my graph going to start and where is it going to end? And then that will be your domain. And when you're thinking about range, it'll be the same thing, but for your y-axis. And that is my answer. Peter, back to you.
Thank you so much, Simone. Wow. So what I'm going to do is I'm just going to briefly explain I have our comments. Okay, so the main topic for today is hyperbolas. And so I'm going to attempt to start talking about hyperbolas, and domain and range also applies to hyperbolas. But before we do that, I want to ask some questions. So I'm going to have a point A, a point B, a point C, and a point D. And I want some students to come online and tell me what they know about the XY coordinate in quadrant 1, or in that quadrant where A is. And then I'd like another student to tell me about what they know about the coordinate B in quadrant 2. Let's just wait for some students to put their hands up and see what they say. So Londi, I see that you have your hand up. What can you tell me about coordinate A and coordinate B? Can you unmute, Londi? Okay, so Modudu has said A, both X and Y are positive. Yes, X and Y are both positive. What about B? What do we know about B's coordinates? If we call this quadrant 2, we call this quadrant 1, quadrant 3, and quadrant 4. So in the second quadrant, X is negative and Y is positive. Okay, what about the point C? What do we know about the coordinates of point C if it's in quadrant 3? So let's go to Hyperbola or Hyperbola. Do you have an idea on question 3 or on point C. So I see that we're seeing it's both negative and negative. And what about point D? So for point D, X is positive and Y is negative. Yes, Ayanda, this is a lot like the Cartesian plane with trig, exactly. Now, give me a thumbs up if what I've said about A, B, C, and D makes sense to you. So if I had the point D, D would have to be something like 3 minus 4. Whereas if I had something like C, that would have to be like minus 3 minus 4. B would have to be something like minus 2, 2. And A would have to be something like 2, 2. Okay, now, this is really important for hyperbolas. So I'm going to get rid of my abstract coordinates, and I'm just going to leave the made-up ones that I've got here. If I multiply the X by the Y coordinate in quadrant 1, do I get positive or negative? So if I multiply the X by the Y, do I get a positive or a negative in quadrant 1? Yeah, because it's a positive times a positive. And in quadrant number 2, if I go X times Y, do I get a positive or a negative? So now we've done quadrant 1, we're going to quadrant 2. Okay, this one, it has to be negative. Yeah, because negative times a positive. Okay, what about quadrant 3? If I multiply the X by the Y, am I going to end up being positive or negative? Okay, I have to be positive. And in quadrant 4, if I multiply X by the Y, what do I get? Aha. Okay, well, ladies and gentlemen, you have just learned the most important thing about hyperbolas. If your hyperbola, and I'll teach you later how to draw it, is negative, it has to be in quadrant 2 and quadrant 4. If your hyperbola is positive, it has to be in quadrant 1 or quadrant 3. And the reason is that the formula for hyperbola is just X times Y equals K in its simplest form. Sometimes we write it differently, but really hyperbola is just when we multiply two coordinates pairs together and we get a constant. That's really what a hyperbola is. So give me a thumbs up if you understand why a positive hyperbola has to be, the green hyperbola has to be in quadrants 1 and 3, and it's positive. And hyperbolas that are negative have to be in quadrants 2 and 4. Because often students don't seem to understand this, and so I just want to point this out to start with. Okay, that's good news. Great, that's fantastic news. Okay, now, obviously, when we see a hyperbola in class, often the teachers, instead of writing it like y equals k, they write it like this, like y is a over x, and they sometimes write it with, they'll say like b times a, and then they'll also have a plus q. Let me actually leave it like that. So sometimes they also write it like this. And that's just going to be, in fact, let me actually move it like this. So sometimes they write it, sorry, everyone, I'm actually moving. So you can write it like that. And sometimes hyperbolas are written with an A instead of a K. So sometimes they write them like that. So those are a couple of different ways hyperbolas are written. I'm worried that I might have confused some people. So just give me a thumbs up if you understand that these two are the same thing. I'm just using A and letter K as different variables. So just give me a thumbs up if you understand that this and this are the same thing. It's just that A and K are the just different things, different variables, names. Okay. Now, if we normally talk about shifting graphs, what are the two? Yeah, they're calculated the same way, Tando, exactly the same way. What are the normal shifts that we have to do to normal graphs? Like, what are the main shifts that we always seem to have to do that we normally include in the standard form? So normally we have to be able to do a vertical shift and horizontal. Yes. So if we are dealing with a hyperbola, the standard form for hyperbola looks like that, where the x plus p is the horizontal shift and the plus q is the vertical shift. Okay. So this reminds me a little bit about parabolas in that it's got a horizontal shift and a vertical shift. The only difference is that the x seems to be below the line. Okay, now, what we're going to do now, we're not going to have any breaks today because obviously there was a bit of disruption, but let me show you how I would draw this hyperbola over here. What process would I use? Now, at the moment, this isn't a very exciting hyperbola. The only thing that I'm looking for is I'm looking to see first, is it a positive or is it a negative hyperbola? And in order to know whether it's a positive or negative hyperbola, I look at this number. Is this a positive or negative hyperbola? Tell me in the chat. Yeah. So because the number above the x is positive, and remember what we said earlier, if it is a positive hyperbola, it's going to end up being in these quadrants over here. But I'll show you how that's affected in a moment. So it's a hyperbola. And now what we want to know is, what does this 1 do? Well, the 1 shifts the whole graph up. So in fact, let me go right from the very beginning. I'll show you my 4-step process. What I do is, for step 1, I want to know what are the quadrants that I'm dealing with. And we know it's going to be in this quadrant and that quadrant. Okay, now, step number 2 is that hyperbolas have asymptotes. And normally, the asymptotes are on the x-axis and on the y-axis. But because of this plus 1, there is going to be an asymptote that goes here. And my asymptotes are going to be when x is 0 and when y equals 1. And the place that I get that from, the y equals 1 is over here. And the x equals 0 comes from the division down here. Now, if you don't get this straight away, that's fine. I'm going to do a second example after this. I just want you to follow me on this process. Inga's asked, do we do the same steps of the parabola for the hyperbola? It's similar, but not exactly the same. So step 1 is what quadrants. Step 2 is what we call the asymptotes. And I'll show you how we use them now. What do you think step 3 is going to be? Step 3 is going to be the intercepts. Now, if I want to find the y-intercept, I normally have to make x equal to 0. But there's a problem. Can I make x equal to 0 here? Or why can't I make x equal to 0? Who has an idea about why we can't make x equal to 0? Let's go to Orokanisa. Orokanisa, why can we not have a division by 0 or x equal to 0 here?
Hey, sir.
Hello.
We can't have that division because there are no y-intercepts.
Okay, well, you can't make x 0 because if you made 0, it would be dividing by 0 in the denominator. But you're right, there's no y-intercepts here because you cannot make x 0. Does that make sense to you, Kanisa?
Yes, sir.
Fantastic, fantastic. A couple of people have said it's undefined and various other things. Now, if I want to find the x-intercept, what I need to do is I need to make y 0. So let's make y 0. And I want all of you to try and solve that equation for me. Try and solve that equation for me. How would I solve 1 over x plus 1 equals 0? There's a couple of ways we can do it, but Okay, so I think one of the ways to do it is to move the x across like that, and then get it like this, and get -1. Or you can ask yourself here, what value must x be so that 1 over that plus 1 gives me 0? And some of you will see that this has to be -1. Okay, now, this is the wonderful thing. When you've done the groundwork, all you need to do to draw this is the following. So I'm going to draw this hyperbola, and what I do is there is an asymptote where x is 0, but x is 0 is on that line, so we don't draw it. Sorry, there's a one where, but we do draw one when y equals to 1, which is this line. So I draw my asymptote. Then, if you think about which quadrant your hyperbola has to be in, it has to be in this quadrant and this quadrant. So I draw my hyperbola like that. And now, what is this red dot over here going to be? Well, it's going to be the x-intercept over here, which was -1. And so the equation of my hyperbola is 1 over x plus 1. So the fourth step was to draw the graph. So the question from earlier, what are the steps that I follow? Well, step 1 is asking yourself, what quadrant is it in? Step 2 is to find the asymptotes. Step 3 is to find the intercepts if there are any. And step 4 is to draw the graph. And when you draw the graph, you just make sure you're putting it in the right quadrants. But the asymptotes do shift where the quadrants are going to be. So it's not just in here, the quadrant actually shifted up over here. Okay, now I don't expect all of you to be comfortable yet. We'll talk about axis of symmetry later. I want to ask you some questions about a second example and see how much of that first example made sense. So, question 1, what quadrants will the graph G be drawn in? What quadrants should I be drawing this graph in? This is step 1 of the second example. Tell me in the chat which quadrants I should be in. So it's going to be quadrant 1 and quadrant 3. Yes, because this number over here is positive. Okay, second question. I want you to write down what are the equations of my asymptotes. And I'll give you a hint. For the y1, look here. For the x1, look here. So what are the equations of my asymptotes? So it's definitely going to be y equals 4. And the other one, sneaky, is going to be x is 8. So it's not x is -8. Now, this is important. So let me draw attention to it. When you want to know what the x asymptote is, you ask yourself what number will cause this to be division by 0. So 8 minus 8 is 0, which means the answer must be 8. You don't write down the number that's there. You write down the number that will cause this to have division by 0. So the two asymptotes are y equals 4 and x equals 8. Give me a thumbs up if that makes sense to you. Or at least after I've explained it makes sense to you. Not quite. Okay. But so what you want to ask yourself is what number, if you put it into the denominator, will cause division by 0. And so because 8 minus 8 will give you 0, it's going to be x is 8. Okay, so I'll just show you the next one just in case. If you look at this next example I've got down here, all right, what do you think the one asymptote would be y equals -3? What's the asymptote going to be for x coming from this bit? Let's just test if everybody understands what's going on with this. Yeah, it's going to be minus 1. So let's just do some practice finding asymptotes before I go back to drawing the graph. If I look at this one, what are my asymptotes going to be for this one? Okay, so y equals minus 2 and x equals minus 4. Yes, exactly. Okay, so I think everyone's got it. I can see in the chat that we are seeing some happy voices. I just wanted to make sure that that was clear. Okay, so now, where were we on our journey? Okay, step 3 was find me y-intercept. So if I want to make the y-intercept, I go y equals 8 over 0 minus 8 plus 4. So what's my y-intercept going to be? What's my y-intercept going to be? So we have 8 over minus 8 plus 4, which is minus 1 plus 4, which is 3. Okay, so we seem to have 3 for my y-intercept. Can you find me the x-intercept? What do we need to do to find the x-intercept? We need to solve the equation. So over to you guys. Find me the x-intercept, and then we're going to draw. Notice how I make y naught to find the x-intercept. So does y have no values because of the error when it does not have a value next to x? Okay. In the previous example, there was no y-intercept because there was no, you couldn't make x 0 in the question. So if you look at the question above here, the previous graph just had 1 over x. And so because you couldn't make x 0, you couldn't get it. But in this one, if you make x 0, there's still the minus 8 next to it, which means that you can find a y-intercept. The y-intercept is going to be 3. Now, for this next one, you have to ask yourself, I mean, there's a couple of different ways we can do it. I think most of you will probably do it like this. So I don't know if maybe tell me in the chat if you would do something different. But that was what I was thinking initially. Bring the minus 4 across. And what do I have to do next now? I was thinking we could do that. Or you could ask yourself, some of you might be able to spot this. Some of you might say, I know what minus 8, so 8 divided by what minus 8 gives me minus 4. And you might get the answer, but I think a lot of us will probably want to take the safe method, which I'm doing here. So what do we have here? 8 minus 32. Okay, so this is 6. So I get that my x-intercept is 6. All right, now we've done all the hard work. Now it's time for the fun thing of drawing. So how do we draw this? Okay, well, step 1 is we need to put our asymptotes in. So my asymptotes are at y equals 3. So there's my y equals 3. And then we have it for x is 6. Now, where was x is 6? Say over here. Give me a thumbs up if you followed what I've done so far, and you can see how I'm kind of marking out my territory so far. Give me a thumbs up if you're with me. Okay, now, I've drawn my asymptotes, but now I need to decide what quadrants am I in. Oh, but I decided that at the very beginning, which is good news for everyone. So I know I'm in quadrant number 1, but quadrant number 1 just looks like it's in a different place this time. And I'm also in quadrant number 3. Okay, so what is this dot over here going to be labeled with? What is that dot over there going to be? What's its value going to be? Oh, sorry, I made a mistake. I see some of you have spotted it. I've been writing in the intercepts there. I should have written in. So this should have been, my intercepts y should have been 4, and this should have been x is 8. Thank you for spotting that, Artie, and a couple of other students, Tivazo as well. Okay, what is this black dot over here going to be? What do you think? What value is that going to be? Who has an idea? It's going to be 6, yes, because you worked it out. It's the x-intercept. Yes, people, we are doing well. I like it. Now, what about this dot over here? It has to be 3, yes. And the label of this graph is just G. And that is it. We have drawn our second hyperbola. Now, one of the awesome things about this process is you can just see the steps. And in some ways, I think this is easier than the parabola. In the next lesson, I will talk to you about axes of symmetry. So hyperbolas do also have something called axes of symmetry, but I don't want to do too much in one lesson. So I'm going to leave that till the next lesson. But for now, I think it's time for us to do at least one more before the lessons today. So what I want to do is I want us to draw, let's draw J. So there is graph J or function J, and I want you to do the 4 steps by yourself and see how far you can get in doing those 4 steps and starting to draw the graph. Before we finish today, I will give you the answer to that one, and then we will continue with hyperbolas in the next lesson.
Peter.
Yeah.
Just a quick question. Do you still want me to do the poll?
I think at the very end, yes, we can squeeze it in, hopefully. But if there's, let's see how it goes.
The poll that was discussed in the group about.
Oh, no, don't worry about that. That's fine. I think we've done, you did outstanding jobs. I think yeah. And also we've learned about hyperbolas, which is fine. Yeah.
That's good.
Someone was asking about going back to take, wait, let me move these out the way so that you can see the previous, if you want to take a screenshot. While everyone else is working out. There we go, Annie. You can take a screenshot if you want. Ask yourself step 1, step 2, step 3. so step 1, we have to be in those quadrants. Step 2, my asymptotes are at that point.
Peter, just in case you missed it, there was a question in the chat asking to explain how to find asymptotes.
Okay, so if you look at the standard form of hyperbola, the y asymptote is super easy. It's whatever this number is. So if it's +3 or -3, you just write it straight down. But if you want to find the x asymptote, you say what number, when you put it in here, will make this denominator 0. And so because 1 minus 1 is 0, this has to be x is 1. Then the third step is going to be to find my y-intercept. And for that, I need to make x 0. And so I get -2 + 3, which is 1. And then to find my x-intercept, I need to make y 0. Now that's the trickier one. See if you can find me my x-intercept. And then from there, we're almost ready to finish off for today. Okay, so we're running a bit short on time. So what I'm going to do is I'm going to tell you that x is 1/3. If you're unsure of the working, you can look at that, but I just want to finish with this today. So if x is 1, I put down my dotted line here. So there's x is 1, that's my asymptote. And then y is 3, which is this one here. And then you ask yourself, where am I drawing this? Well, it's in quadrant 1. So it's going to be over here. And it's also going to be in quadrant 1, and then it's going to be over here. So I get that. And then this this y-intercept was 1. So that's going to be 1 over there. And the x-intercept was 1/3, which is here. And then function is called the function j. And that's it. So Karabo, don't worry. In the next lesson, we're going to carry on drawing graphs. We're going to do about half the lesson drawing graphs and half the lesson finding the equation. So we're going to practice more. What I say to my students is put down the asymptotes first, and they tell you where to do. And then just kind of think of a half moon. It doesn't have to be perfect, but you just kind of think of it as kind of a half moon or like a banana. Feel like you're drawing a banana. Like, there we go. Then you're good to go.